Hello, this is IK Tutors, and we are doing a algebra assessment. This is completing the square, or actually solve by using the completing the square method. Okay, so let's begin. The question states they want us to solve by using the completed square, and they give us two quadratic equations, right? Or part of quadratic equations. X squared plus 6x equals minus 8, and 28 is a squared plus 4a equals 5. So how do we do this? Well, we first must realize that whenever we're asked to solve a quadratic equation, we have to first factor it. So we're going to go ahead and factor this first, and then once we finish factoring, we're going to go ahead and solve. So let's get started. We're going to factor these equations all together, right, as a group. Usually we can do about 5 or 7 of them all in one shot at the same time. So we're going to do both of these at the same time. How do we do that? We get the b value, right? Because before we can factor, we have to complete the square. That's the complete the square method, is by adding the missing value of c. So to get the missing value of c, is you see here, the equation says c equals b over 2 squared. We have to get the b value from the equation. So we're going to go ahead and do that now. The b value for 27 is 6, positive 6, and the b value for 28 is 4. Now we're going to go ahead and plug that b value into the equation. So c equals b over 2a here, b is 6. And for the other one, c equals, again, b over 2a here, b is, I'm sorry, not 2a, b over 2 squared. Here, b is 4. Now we're going to see if we can simplify these amounts inside the bracket to a whole number. Well, 6 for 27, 6 over 2 does give you 3, so we can simplify that. If we couldn't simplify it, we would just leave it as is. For 28, we can also simplify that c value. So it's going to be 4 over 2 is going to give us 2 squared. So now we have our c values, and we can go ahead and complete the square by adding the c value to the equation. Now keep in mind, there's an equal sign here. So whenever we do perform a operation on one side of the equation, we have to perform the same operation on the other side. So when we add the c to one side of the equal sign, we have to add the c to the other side of the equal sign as well. All right, so let's begin. For 27, the c value is 3 squared. So we're going to put, and we have to keep it in this notation, open bracket, 3, close bracket, squared. We have to keep it there. We don't square it out, right? And then we're going to add the same amount. Whatever we add on one side equal sign, we must add on the other. So we're going to add the same amount on the other side. So it's going to be, again, we add open bracket, 3, close bracket, squared. And for the 28, we're going to do the same thing. We're going to complete the square by adding that missing value of c. So for 28, the missing value of c is 2 squared. So again, we go open bracket, 2, close bracket, squared. And then on the other side equal sign, we have to add the same amount. So it's going to be open bracket, 2, close bracket, squared again. So once we completed the square, now we can factor. And keep in mind, whenever we use this formula to compute the c value, and we take that c value and complete the square, we get a special quadratic equation called the perfect square trinomial, which is great because then it factors out really, really quickly and easily. Normally we have two binomial factors, so we put the brackets there, right? And then we would figure out what the values are. However, because this is a perfect square trinomial, both of these factors are going to be identical. I'll show you what I mean. When we're factoring a perfect square trinomial, all we need to do is look at the first, get the variable. So the variable is going to be x. We get that from the equation, and then we take the value that's in the c in the third term. So this is inside the brackets in the third term. It's a positive 3. So it's going to be positive 3 and positive 3. And there you have it. It's factored, right? However, remember what we said. They're identical. So we can represent these two factors as x plus 3 squared, just like that. Right? So we're going to do that for both of these. Since both of these are going to have identical factors, we can just use one set of brackets and square it. Let's go ahead and do that. Okay, so now they're both factored. That we're taking care of that. Oh, we didn't factor the other one. So over here, 28, they're not both factored yet. We're going to go, the variable is a, and then we look inside the bracket here, and we see that it's plus 2. Now it's factored. Okay, so now we're going to simplify the right side of the equation. It's just numbers there, so we're going to go ahead and put equals, right? And then we're going to simplify it. So 3 squared is 9, and minus 8 plus 9 is going to give us a positive 1. Now we do the other one. This is a perfect square, by the way, positive one. In fact, whenever we do the right side, we should always get perfect squares. If you don't, there's something wrong, so you should go back and check. This is a good way for testing yourself as you're going through the problem. So we're going to do 28 now. 2 squared is 2 times 2, which is 4. And 4 plus 5 is 9. Again, a perfect square. So we know we're going in the right track. Now that we completely factored both of these, now we can go to phase 2, which is to solve. How do we solve these? We just solve them like we would solve any other algebra equation. We're going to look at the variable side equal sign, and we're going to do the opposite of whatever math operation is happening. So we look over here, we see it's being squared, and we're going to do this in the order that PEMDAS tells us to do it. Remember, PEMDAS, or please excuse my dear Aunt Sally, right? When we're solving, we start from right to left, right? When we're solving, and that's what we're going to be doing. So the first thing we encounter is that this whole thing is squared. So that's an exponent. So we got to take care of that first, right? So we go ahead and we take the square root of both sides. You could also say that the first thing we encounter is the parentheses, but we can't do anything until we get out of the square. So we're going to go ahead and put square this is going to be x plus 3 squared equals, and now we took the square root of one side of the equal sign, now we have to take the square root of the other. And when we do the square root of the number, we always put this plus minus here. So that's going to be square root of 1. And now we can go ahead to square, cancels out with the square roots. We just get what's inside, which is x plus 3. Plus or minus square root of 1 is 1. Now we can go ahead and solve the rest of this, right? Again, we're looking at variable side equal sign. We're adding 3, so we do the opposite operation and subtract 3 from both sides. Plus 3 and minus 3 cancel out. We get x equals. Now, we cannot add these two numbers together on the right side because this plus minus means that these are not like terms. Okay, so we're going to put the negative 3 first, and then we'll attach the plus minus on the end. Plus minus, and this is our answer for 27. Now let's go ahead and do that technique again for 28. We're going to take the square root of both sides to do the opposite of the square. Right? And when we take the square root of the number, we go plus minus. Then we put the square root of 9. Now, the square root of something squared, like I said, they're inverse operations, so they cancel out. We just get what's inside. So we're just going to get a plus 2 equals plus minus square root of 9 is 3. Now we're going to solve, right? We're adding 2, so we're going to subtract 2 from both sides. We get a equals minus 2. Then we attach the plus minus part, plus minus 3. And that is our answer. Okay, so I hope this helped. If it did, please remember to like and subscribe, and I will see you in the next video. Have an amazing day.